After the move operations, we are actually going to convert things. So we can go for the conversion operations. First thing will be the convert, and I'm using the convert, and we have two things, input and output, and here we can declare what to convert from what to what. That is a question mark, two set of question marks there. So I'm using integer. I just want to convert integer to the BCD numbers. So the BCD is 16. So I'm using an input MW0, that should be converting to MW2. So that we get the BCD values in the MW2. So let's see. So here we can see we will be going to convert these things into BCD. So we have MW0 and 2. While we are giving 10, we are getting the BCD value as 16. Okay, that is the BCD numbers. If you are giving 20, we get 32. That's it, we get 32. That is the BCD number. If you are just confusing how these BCD numbers are coming, let me show you, let me explain you how these BCD values are converting. Like if I just given 20 or 10, okay, leave it 10. The binary number for the 10, which will be 0 1 0 1. The 1010, this will be the 10, because the fourth one holds the power of 8, 4, 2 and 1. 8 plus 2, which is equal to 10. So while we converting these things to the BCD, we will be splitting these things. Okay, we will be splitting these things. The fourth bit, that means that will be converted to 16. Okay, the fourth bit is actually 16. Here you can see we have 10, and we will be splitting these two numbers 1 and 0. The 1 stands for 1 0 0 0. This is the binary for 1, and here we have 0. All the things will be 0. So the sum will be equal to 1 0 0 0 and 0. 4 zeros are there. This one holds the power of 16, and 8 has no power, 4 has no power, 2 has no power, 1 has no power, because while we are giving 10, we get 16. While we are going to 20, we get 32. 2 is splitted into here, and here 0 is splitted here. Here you can see 20, 0, 0, 1, 0 is for 2, and for 0, 0, 0, 0, 0. So the after 16 we have the second value, that is 32. 32. If it is 22, if it is 2, 2. If it is 22, we will be getting the value as 2, 2. Here 32 plus 2 equal to 34. For 22, we will get the 34 for the BCD. These BCD numbers, we see 22, we get 34. The BCD numbers are, we are using this kind of BCD number for connecting the 7 segment displays. Like this, BCD numbers have only 4 feeds, only 4 inputs. So this is connected to a 4 by 4 divided by, or 4 by 7 segment display. 7 segment display, that is used for showing the digital displays. This kind of digital displays will be available in our wristwatches. Digital wristwatches we will be encountering. You can see this kind of digital displays that is used for showing the digital values. For this kind of application, we are using the BCD conversions. Okay, just for showing into the digital values. Okay, this is a 7 segment display. You can see this kind of stuff in the watches. So it will be converting the 4 BCD numbers into 7 segment. 1, 2, 3, 4, 5, and the last one is 6, not the last one. Here we can see 7. This is the 7 segment decoder. That's why we are using the 4-bit BCD number. Okay, BCD is binary coded decimals. For that we are using the BCD numbers. So we can go for the next one. It's important things in the Siemens, that is the conversion blocks. This is the round, seal, truncate and floor. Sorry, floor and truncate. We can go for the round thing first. Round input would be MD0. That means only this real thing can be only be rounded to the double integer or any double thing. So MD4. So the real thing should be round into MD4. This MD4 is not in the form of double integer, that should be in the real. So MD4, that should be in the real. So I can change it to double integer. DINT, and coming back to main, and let's see how it is getting converted. The rounding of means you will be see if we have a point value like 5.5 or above, that will be we will be getting the value as rounded as 6. That is a round off. Simply it's round off. So let's see. So I do have MD0 in the real format and MD4 in the decimal format. So I can show you on and off. I'm just providing a value like 5.2 I'm giving. We are getting the result as 5. Okay, nothing bigger. If I am giving 5.5, that will round off to 6 or the very next integer. Even the point value consists of 0.5 or above, we get the result as the very next integer. That is a rounding off. So you can simply go to the very next thing. That is the after the round block you will be encountering the seal. Seal is related to sealing. Okay, so MD0 and this will be MD4. The seal means that value should be sealed into the upper level. If it consists of a point value, even if it is 00001, we get the output as the very next integer. That is a sealing. This kind of round, sealing, truncate and scale, this kind of things used for converting these blocks or converting the analog inputs. Like if you have a temperature of if you do have a temperature of 20,000 or 2005.68 degrees Celsius or Fahrenheit, whatever. So if you have this much temperature, we don't have to display this. Okay, the point value, because it's a huge temperature. Okay, it's a huge temperature, so we can actually scale or you can actually truncate or eliminate these point values. That's why we are using this kind of conversion blocks. So the value final result will be getting as 2006 degrees. Like this application, for displaying application, we are using this kind of application. You can see the seal means if the point values, and just giving the simple 5, if you are using 5 or 5.0, you will be getting the same output. If you are giving any point value, 5 point, the last bit of the point I am changing it to 1, and okay, and 5.000001, you will be getting 6. That is a seal. Seal means even if it has a point value, a minute point value, that will be sealed to the higher integer or the next integer. That is a seal. And we can go to fix it to the floor, and I am making it to the floor and run. Let's see what is the floor. Floor is exact opposite of the seal. That means even if the input has the 0.999 or any huge value, that will holds the same value. That is the flooring. It keeps the value down. So 5.999 I'm using. Even if it has 5.9999, see, even if it has 5.9999, it's almost 6. We're getting only 5. That is the floor instruction. So we can go to see the very next one. That will be the truncate. Truncate is almost similar to floor. Truncate means just eliminating. That's it. Truncate. Whatever the input has a point value, that will eliminate. Truncating means cutting off. That is the exact meaning for truncate. That is the cutting off. So even if it has any value, that will cut off, whatever the value be. Okay, that will cut off the point value. Only the value we are getting as the point or the normal integer value. And these are the main blocks or the main conversion blocks we are examining through the Siemens TIA portal.